technologies we have is something called Trip Optimizer, which is like an intelligent cruise control system for trains. So it automatically controls the throttle, the brakes, the various locomotives in a consist. And we're taking data from the physical asset, how many trains there are, what's the weight. I'm taking data from external. Broken rail or rail that's getting depressed. Now, right now, in the industry, we have to physically go out there with specialized vehicles or people to go out every day to inspect these tracks, and they spend millions of dollars a year. And it's a lot of track, right? 250K of track in the US, in China over 120K miles of track, in India, the same, over 120K. These are problems. So how can I apply some new concepts? So how can we use trains and video to monitor the track instead? So this is an application where we already have high-definition cameras on the front of the locomotive, taking video of that track every day going down the track. And we have multiple locomotives going down the same path every day. So you go, you know what? How can I use this video to monitor the track instead? So a couple of scenarios. First, we use things like computer vision techniques. So on the left side, you see one of the things to measure is track gauge, so how far apart the tracks are, and to see if there's any dispersions in that. For 25 years, and we've already been surpassed in terms of the amount of revenue. So we're at 120 billion in revenue. And so within the last 20 years, Amazon has been able to get to the same size and make the same amount of impact, but has done it in 1/5 the time. So in many ways, the industrial challenge is how do I go through the same transformation, and what technologies can we use so I can help make up that 100-year gap that Amazon caught up. But one thing I'm really excited about is in the industrial space, there's actually quite a bit of potential. Okay, right now in consumer space, it took about 20 years to connect 3 billion internet devices. So if we look at the industrial side, right now there's opportunities of 50 billion devices that we predict will be connected by 2020. And they're going to be putting off 2 times the amount of data, right, in industrial data growth. And if we look at things like we look at the sensors coming off, we look at ERP, traditional enterprise systems, all this data is coming into, whether it's the cloud or on-premise, and you see things from like 1 terabyte of data coming off an aircraft each flight. In the rail space, we have over 9 million sensors on a locomotive, and that's actually advertising revenue models, where in the rail space and these industrial businesses, how do we provide value? And so, we have the traditional situation where we have a gateway on locomotives, cameras on the locomotives. How do I bring that video back to the cloud in an economical fashion? Which degree of processing do I do at the edge versus in the cloud? So that everybody thinks about the cloud as being very easy to do this deep analytics, but the reality is it just costs too much to bring back this data. These industrial companies are not yet ready to pay for a lot of this. So we have to think through how do we make it economical for video to go from the edge to the cloud, to do the analysis, and then to be able to feed that into tangible actions that a field service person could do, or any of the technicians. Also, privacy and customer data is very important, and it's also a big issue for industrial companies versus, let's say, the consumer companies. Lastly, model accuracy. Right now, we're having a very difficult time, convincing our customers or industrial companies, hey, this is something that can provide value today. Even we are at places where we're over 90% accuracy for rail detection, for thermal misalignments using video, but they're not there yet. Customers need to be educated. So one of the things I would say is, for the audience today, I would challenge you that companies like ourselves, all the industrial companies, need your help. Right? We need to not just think about some of these consumer use cases. We need to think about ways where we can think through the business model. How can I make this the outcome? Is it real today? How do I educate all the different folks in the industrial space to take advantage of the big opportunities? So in summary, there's really great opportunities to create these digital twins. So a digital twin of the locomotive, it could be a train, it could be the physical rail assets on the side, and also this broader ecosystem. So if I think about it, I start with the train, I can go out to a yard, a rail yard, a terminal, a port. All of these have opportunities where I'm actually creating a big assets that can be tracked, can also be modeled, and then we can also manage the life cycle and the virtual life cycle of these digital assets throughout this big ecosystem. So thank you very much. I just wanted to give you a little bit of an overview of the applications of AI in the industrial space, and I'll be free for questions afterwards. Thank you.
这个非常感谢基业的分享。我们下面从铁路到更一般的这个公路，那么请这个 Nevada AI City 的CTO Melinda Nafeda 给我们讲这个 AI in Transportation， 大家欢迎。
Ni hao, Beijing. I know that I stand between you and lunch, and that's not a very good place to be. So I'll try to make the presentation as interesting as possible to make you forget your hunger for 30 more minutes. I want to start by thanking Zhao Yunfeng and the entire team of Synced. They have put together a really memorable event here, and I am really happy to be delivering this keynote at the Global Machine Intelligence Summit this year. My name is Milind Nafte. I work for NVIDIA. I'm the Chief Technology Officer for AI Cities at NVIDIA. Prior to working at NVIDIA, I was at IBM Research for a very long period of time. And in the last 25 years, I have spent in AI. It has ranged from semantic video analytics to smarter planet solutions. And now I am at NVIDIA. So if you happen to be in the world of artificial intelligence, there's no better time than now. And I can tell you there's no better place than NVIDIA to be. So let's start the presentation. We have to really take a pause here. Throughout this morning, we have heard fantastic presentations. But I just want to take us back in time. When I was a student and I started implementing my first neural network, I remember it was 25 years ago. So, of course, I'm really old now, as you can tell. We didn't have any GPUs back then, right? It was, I remember my first backpropagation algorithm implemented on transputers, where we had to think about message passing so that we could parallelize the load on the system. We had 3-layer neural networks. We had data sets that were tiny as compared to what we see now. And I have been through this whole journey where we have gone from multi-layer perceptrons to Vladimir Vapnik's work on support vector machines. And I've been part of the generation for almost a decade. It felt like SVMs were the way to go. Graphical models were the way to go. And then suddenly, in the last few years, we have seen the pendulum swinging back towards the connectionist architectures in machine learning. So what really happened? What really happened were 3 things. The first, of course, was the deep neural networks and the algorithms that powered these architectures. Large labeled data sets that made it possible to learn these complex networks. And last but not the least, the GPU. As I was saying, when I was a student, it was impossible to train models this complex, even for smaller data sets, without leaving the machines running for months to build the models. And GPUs made that possible to train these machines within a matter of hours. So these 3 trends really ushered the era of deep learning. And as you can see, we have gone from strength to strength. Here you see a simple convolutional neural network. Why is this so effective? Why is this so powerful? Well, first of all, you don't have to handcraft features. The deep learning algorithms are able to do feature learning as well as classification. So it takes away a whole bunch of complexity away from the designer of the algorithm. Second, it is able to hierarchically abstract to various levels of abstractions of the patterns. So here, if you go from that end of the network to the other end, you start seeing edges being extracted and then complex patterns being extracted to the point where you finally see that the network can classify that this image has a Volvo XC90 in it. So it is this really powerful ability to do feature learning and to do classification jointly, the ability to represent directly from the data set and increasingly complex abstractions of the data that makes deep learning so powerful. But why is it that we are seeing so much energy, so much work in this area? This is what our CEO, Jensen Huang, calls the big bang of modern AI. In just a matter of few years, we have gone from convolutional neural networks to recurrent neural networks. We had Jürgen talk about LSTMs this morning. We have autoencoders. We have reinforcement learning. We have generative adversarial networks. Generative adversarial networks, or GANs, as they're called, are one of my really, really favorite type of neural networks, where you have the notion of 2 neural networks competing with each other. one trying to fool the other trying to catch the mistake. So you can think of one as a forger and the other as the detective. It's just beautiful, beautiful paradigm. You have residual deep learning. So it's just the amount of work that's happening in the last 6 to 7 years is so vast and so deep as a full-time job. Every day I wake up, there is a new learning algorithm. Every day I wake up, I anticipate that deep learning has defeated humans at yet another task. And what an amazing set of accomplishments we have seen. We have seen being able to do superhuman image classification. We have seen superhuman speech recognition. We have seen superhuman performance in beating the world champion at various games, Go being one of them. We have seen the ability to transfer the style of the masters. So I could paint a Monet one day without being as good as Monet, thanks to deep learning. I mean, how great is that for somebody who is terrible in painting, like me? You have seen synthesis, voice synthesis that is so real and can be trained so quickly, it is really difficult to tell the difference between a human-generated voice and a computer-generated voice. We have seen language translation. So it's just this explosion of applications. It's the challenge to human performance, which is why I can say very confidently that every industry, every vertical will be impacted by this big bang of modern AI. And so today we talk about just one of these industries, the transportation industry. Now, as my colleague from GMIS was saying before me here, transportation is a very, very complex system of systems, right? We are all very enthralled by the consumer applications of AI, but when you go to the industrial applications, when you look at transportation as a complex system of systems, the challenges are huge, and so is the potential. In the world of transportation, you have vehicles. These are your cars, your trucks, your ships, your aircraft, your locomotives, and your drones. You have infrastructure. These are your bridges, your roads, your tunnels, your ports, the buildings. This is really the backbone of your transportation. You have the signaling and systems. Wes was talking about fuel efficiency. The whole notion in transportation is how can I optimize the flow and how can I optimize the volume with the metrics that I care about, whether it is fuel efficiency, whether it is environmental impact, whether it is time to reach from origin to destination, so on and so forth. The fourth part is, of course, people. We all. And we are talking about new paradigms of mobility as a service. As the Ubers and the DDs of the world take over the problem of taking us from home to work, the notion of ownership of vehicle will transfer to more of mobility as a service. And finally, last but not least, freight and logistics. The average American meal, I was surprised to read this, it takes 1,500 miles to get from farm to plate. Moving stuff around is actually a hugely complex and very, very large business in and of itself. So when we talk about transportation, it's all these interdependent systems that we need to consider. And when we talk about AI in transportation, that's all about making each of these smarter and safer. And what AI means for each of these systems is different. What it will do for these systems is different in the way it will revolutionize them. So we are all, of course, very, very excited by the potential of AI in vehicles, right? Autonomous vehicles. But when you look at predictive maintenance, that to me is a very, very key aspect of AI in infrastructure. And we saw one of the examples in Wes's presentation just a few minutes ago. When you look at AI in signals and systems, imagine the world of IoT and the world of artificial intelligence working together so that you can optimize flows and volumes. When you think of AI and people mobility, it's all about making our experiences seamless, making our experiences safer, and making our experiences smarter. You want to get from point A to point B in the least amount of time, with the least amount of effort, and in the most seamless way possible, and of course, be safe at the same time. And in terms of AI in logistics and freight, other than trucks, other than self-driving locomotives, we are also going to see a huge impact of intelligent machines in the handling of cargo. So in my mind, AI in transportation is going to be applied in each of these systems in this way. Let's take a look at some of these examples as we go along. One of the things that, of course, we at NVIDIA are strongly supporting this revolution is through two platforms. One is, of course, our Drive PX platform for auto cruise driving and HD mapping. And the other is the NVIDIA Metropolis platform. Wes talked about how difficult it is to move data from the edge to the cloud. It's very easy to think all the training is going to happen in the cloud and everybody lives happily ever after. That, unfortunately, is not the real world when you have so many gigabytes of data being collected every locomotive, for example, right? So that's why we have announced the NVIDIA Metropolis platform to help with this edge-to-cloud AI platform. So let's look at some of these examples.
Take me to Starbucks in San Mateo.
I wanna live like it's Mardi Gras with a phone call and an entourage. And don't need the R&R to regular life. I say I was. Hey, living life in the fast lane. May your pain only be champagne. So please come join me. One thing, good vibes only. I just cash my check. I ain't paying rent. I just quit my job. Go to the mall, get lost. Don't care who you are. Don't care where you're from. We all got one thing in common. We just wanna have fun. Hey. One thing, good vibes only. I just cash my check. I ain't paying rent. I just quit my job. Go to the mall, get lost. Don't care who you are. Don't care where you're from. We all got one thing in common. We just wanna have fun. Hey. Think about to do it. Think about to do it. Do something crazy.
Disengage autopilot.
Switch up the style. Do something crazy. Do something wild.
So I have a really old car. It's a 10-year-old Subaru Forester from 2007. And every day I have this conversation with my wife, who thinks I should buy a new one. And she has no idea why I'm still waiting, why I'm still trying to get a couple of years of more life out of this old car. Now you know, I'm waiting for this to come out. Now, we'll go to freight. Now, we have to really pause for a minute to think of the impact of this. Imagine all the transportation infrastructure that we currently have, especially in the United States. It was the whole interstate highway system, right? It's built with an assumption that freight, especially truck-based freight, right? People can drive maybe 8 hours a day, 9 hours a day, and then they have to stop. So the entire notion of the distribution centers, the hub and spoke model in them, the expectation of how much freight can be driven in a single day, all of that is going to actually change when we can have autonomous vehicles moving freight. So imagine the impact that will have in the creation of new hubs, in the creation of new distribution systems for this freight. It's a big deal. As excited as I am about the BB-8, this is very, very exciting. Now, when you look at the other different systems that I talked about in transportation, we talked about this. We need an edge-to-cloud architecture. A lot of the problems are not solved without an edge-to-cloud architecture. We look at very simple things, right? We look at parking in cities. We look at cameras that are looking at these places. We look at on-premise systems like traffic management systems, right? Hundreds of thousands of cameras. We look at cloud. Data from thousands of cameras, although you can't really move all those feeds up. But a lot of these applications in these transportation sectors, in these systems, do need an edge-to-cloud platform. And that's why we are really proud to have NVIDIA Metropolis, which is an edge-to-cloud AI city platform. Now, this platform allows you the extremely powerful, the most intense supercomputing at the edge for inferencing in the form of NVIDIA Jetson. It allows you to do the same kind of inferencing using our Tesla and Quadro technology in data centers as well as on-premise. And finally, the NVIDIA DGX for training in the cloud. We believe that this is the first end-to-end AI city platform that allows you to address a large number of transportation use cases. And the idea here is that you will have models that are trained in the data center that can be then disseminated to the edge. But over time, you will also have learning that happens in a distributed form where all the data may never come back to the data center for being trained. So let's look at AI in infrastructure, predictive maintenance.
Is a company that develops and produces commercial drones. We believe in a fully automated drone workflow to enable safer inspection of cell towers, high power lines, wind turbines, and on the end acquire a high quality of data, which was manually done before. Many people die inspecting cell towers yearly, and what we've identified is that a drone is a good replacement to do a first visual checkup of the cell tower itself, to identify objects that are on the mast, to see what the maintenance status is of the objects on the mast, and eventually document them automatically.
We were now developing the Oki. It's the code name of the project, and it's a camera which has a visual daylight camera and a thermal camera. Inside we also have the new TX1 module from NVIDIA, which can be used to gather the data streams of the cameras and process it in the way a customer wants. In big windmill rigs, they use a thermal camera to find somewhere where friction is too high. So when a bearing is wear down or something hits something else, it will generate friction and it will generate heat, and then it will be easy to spot with a thermal camera where you cannot easily see it with a visual camera.
We've been using before FPGA technology, that is a deterministic, really good technology, but really difficult to modify. NVIDIA come with a solution that is really appealing for drone market. A small powerful GPU that has the size of a credit card is fundamental for mechanical restriction that a drone application has, and the efficiency of battery and power consumption are fundamental in such task. Currently we are using the Jetson as a brain of the visible sensor, but in the future we are thinking to use as the skilled pilot that can drive autonomously the vehicle. Deep learning is a new branch, research branch for electronics. We can take advantage of GPU and is real-time processing in a mission such as inspection of cell tower or windmill, where we can customize algorithm in order to facilitate the routine task of the operator.
GPU technology enables us to do different stuff with the drone. So we use the GPU to do image processing, and we can use that to either use the input of the camera to control the drone, or we can use the GPU to smooth your operation and only get the data you need. So then you can train the camera to only focus on rust spots or a thermal signature you want to track down. And you can fly, and then when it sees that signature, it would recognize that from the data bank, and then you can send those pictures back to your service engineer.
Working with NVIDIA allows us basically to accomplish our end goal, creating a drone which is way smarter than they are today. By having the Jetson on board our system allows us to be more flexible, adapt to different markets, and come up with a better end-to-end solution for our end users.
Now this example was about cell towers inspection, but as again we saw in the previous presentation, right? You can imagine the locomotives, you can imagine all the vehicles that are going around our roads, and there is absolutely no reason why we can't think of predictive maintenance and inspection as the most critical AI impact on infrastructure. Let's look at some of the other examples. We all know that whether it is malls, whether it is airports, whether it is large areas where people are gathering, whether there is a lot of pedestrian traffic, it is very important to be able to analyze the data from these hundreds of video streams. It is very important to be able to do that in parallel. And it is very important to sometimes do it in an on-premise environment for data privacy and security concerns. And based on that, make sure that the infrastructure and the people who are using the infrastructure continue to do so efficiently and safely. So that's one of the use cases that our Tesla architecture supports, where you are looking at a very wide network of cameras. And cameras is just an example because it's one of the most intense data streams. It's one of the most voluminous data streams. But you can imagine that if we can handle this kind of camera data from all over an airport, all over a train station, all over a mall, all over a city, we can pretty much handle data sources of other types. Now, we have a lot of partners that are using NVIDIA technology, SenseTime being one of them. Coming to people and mobility, what are we looking for in this mobility as a service world? We are looking to, as I said, be able to go from point A to point B without worrying about ownership of the vehicle by using intermodality. So in this sense, if there is technology that allows the system to look at us, recognize our faces, and allow that for seamless access control, recognize our vehicle's license plates, allow for seamless vehicle flow, this has a huge impact on improving the flow. This has a huge impact on making our experiences seamless. This has a huge impact on how we feel about intermodality as we go to mobility as a service. This also has side benefits. For example, when we are thinking of infrastructure like our ports, airports, or railway infrastructure, and we are thinking of emergency management, disaster preparedness, being able to evacuate large facilities, like this facility, for example, a lot of analysis of this kind of video data for crowd density and so on and so forth can help prepare us for better evacuation planning. So this directly impacts the safety of the people using this infrastructure. Another partner of ours is using this technology to analyze traffic flows at intersections. Now, I don't know about you, but I am very frustrated when I am at an intersection, the light is red, I'm waiting there, and there is no traffic going in the other direction. But the traffic light just won't change. It stays red for that amount of time that it has been tuned to stay red. The timing has been already predefined. How frustrating is that? So in these kinds of situations where you want to be able to control the traffic light based on the flow, this is an excellent use case where you want to have AI at the edge. This is an excellent use case where you can analyze using video cameras and other sources of data. How does traffic flow? At what time of day do you see more vehicles of one type than other? What are the turns that are being made? What is the average wait time for a pedestrian before they can cross the street? This has direct impact on pedestrian safety. This has direct impact on bicyclist safety. Right? So this is one of the areas where AI can really help in traffic flow analysis, both in historic analysis as well as in real-time control of the traffic control systems. And finally, let's just look at AI in freight and logistics. You already saw the video that shows how the autonomous vehicles that start moving freight around are going to have a big impact in the world of freight. But there are other aspects that I was mentioning, including last mile delivery. So this is the last mile delivery example from Starship, one of our partners that is using autonomous last mile delivery. The other aspect is warehouses. Warehouses are very, very large places with a lot of inventory. This is very expensive inventory. Being able to handle that inventory, being able to be on top of, in real time, the knowledge of what is in the warehouse, where is it, it's not an easy problem, right? It becomes particularly harder when you are thinking of situations where you want to be able to move the freight around very quickly. So we have another partner of ours, Intelligent Flying Machines, that has created this warehouse drone, which does inventory analysis inside a warehouse, again using NVIDIA technology. These are two examples that I can share with you. Now, there are other things that you will see in future in the world of freight when it comes to intelligent machines helping with a lot of port-related operations, a lot of port automation in moving the large 20 feet and 40 feet containers on ships to port, from port to ships, etc. So AI is poised to play a huge role in the world of freight and logistics. This is just a small set of examples of where a large number of our partners are delivering various AI transportation solutions. There are examples here like Hikvision and Dahua. There are examples here like SenseTime. We are seeing examples in every aspect of transportation that I talked about being impacted by AI and by the NVIDIA technology underneath. One of the real valuable experiences for me as I have been at NVIDIA is to just learn what a large ecosystem of partners NVIDIA has in this space and what great amount of breadth and depth the solutions they offer brings to the world of transportation. So this is a very quick walkthrough how AI is impacting various different aspects of transportation. As I said earlier, the vehicles, autonomous vehicles, the infrastructure, predictive maintenance, signaling and systems, real-time control, where IoT meets AI, people mobility, keeping people safer and smarter as they use mobility as a service, and freight and logistics. It's all about first autonomous vehicles and then intelligent machines in terms of our ability to make the movement of cargo efficient. These are the various ways in which AI is going to impact and revolutionize the world of transportation. With that, I come to the end of my presentation. Thank you very much. 谢谢。
Thanks，非常感谢缅兰德的精彩的报告。这个今天的这所有的报告我都觉得非常精彩。我是参加过近1000次国际会议，主持也主持过上百次了，但是这样开会我还是真是第一次参加。昨天晚上他们每个人都来了 rehearsal， 这个所以有今天这么好的结果。这样大家下午还有更精彩的报告。1点20开始入会，现在大家 lunch time。Thanks。
大会上午全部演讲到此结束，感谢各位演讲嘉宾的精彩分享，感谢各位观众的认真聆听，请大家于下午1点准时入场。大会将于1点30分正式开始。
Thank you everyone for your participation. The morning sessions have now come to a close. Please return to your seats by 1 p.m. The afternoon sessions will begin at 1:30 p.m.